This problem is asking you to rewrite it using the distributive property and the greatest common factor. Two keywords there. Also, I'm looking at the problem and it's an addition problem, not a multiplication problem, so I do not want to separate it out by place values. So I'm going to go ahead and start by finding the greatest common factor of 45 and 12. I'm going to put them in the ladder. They have a common factor of 3. 3 goes into 45 15 times. 3 goes into 12 4 times. If I look at 15 and 4, they don't have a common factor. The factors of 15 are 1, 3, 5, and 15, and the factors of 4 are 1, 2, and 4. The only common factor they have is 1, so that makes certain you're done. So this is my greatest common factor. Now I need to rewrite it using the distributive property. So I'm going to put my greatest common factor on the outside of the parentheses. Then on the inside, I'm going to put my remaining factors that only have a greatest common factor of 1 back on the inside. This is rewriting the sum using the distributive property. I know that this sum is 57. If I check my math, I have 3 times 15 is 45, plus 3 times 4 is 12, which equals 57. Or I can look at it another way and do 3 times 19, which also equals 57. I can check my math right away. This is my greatest common factor, and these two numbers are just the factors with a GCF of 1. Serena wants to create snack bags for a trip she's going on. She has 6 granola bars and 10 pieces of dried fruit. If the snacks bags should be identical with no food left over, what is the greatest number of snack bags Serena can make? Keyword here is greatest number, which helps me see that it might be a greatest common factor problem. Additionally, if I think about what's happening in this problem, she's already purchased 6 granola bars and 10 pieces of fruit. She's not going to be making any more, and that's what would happen with the least common multiple problem. So I'm going to go ahead and put 6 and 10 inside my ladder. I'm going to pull out a factor of 2 because they're both even. 2 goes into 6 3 times. 2 goes into 10 5 times. 3 and 5 only have a common factor of 1, so I'm done. This is the greatest common factor, which means that this is how many snack bags I can make. Sorry. Then if I look here, my 6 was my granola bars and my 10 went with my fruit. So I can have 3 granola bars and 5 pieces of dried fruit in each of those bags. In this problem, Adina is packing equal number of apple slices and grapes for snacks. Adina bags the apple slices in groups of 18 and the grapes in groups of 9. What is the smallest number of grapes that she can pack? So we're looking at smallest number here. So when I'm looking at that, I'm also noticing that I'm not separating these out into equal groups. I'm not trying to make equal bags. I want to know how many of each I can make so I can have the same amount. So I'm going to use least common multiple for this problem. I'm going to have 18 and 9, and I'm going to start using their multiples. The first multiple of 18 is 18. The second one is 36. The next one is 54. So with 9, my first multiple of 9 is 9. My second multiple of 9 is 18. So here's where they match. So I need one group of apples, and I need 2 groups of grapes. And that's what my problem's asking me. What is the smallest number of grapes that she can pack? If I continued on, I'd find other numbers. For example, 9 does go into 36, but it isn't the smallest one. The smallest one is 18. In this problem, Alyssa's shelves hold 31 books each. How many shelves will Alyssa need if Alyssa has 248 books? So we're looking at each shelf can hold 31 books. So 31 books each is a something that's telling us what to do. Is telling us that we need to divide. And there's a total of 248 books. And the problem says how many shelves. This is key to what number becomes our divisor, because these are talking about shelves. They match. So 31 becomes our divisor. So our problem is set up like this. 248 divided by 31. So when I set up my division house, 248 is my dividend, goes on the inside. 31 is my divisor, goes on the outside. How many groups of 31 can fit into 2? None. How many groups of 31 can fit into 24? None. So now I need to find out how many groups of 31 can fit into 248. I'm going to use my distributive property. I'm going to break down 31 into 30 plus 1. And I'm going to go ahead and multiply it by 7. So when I do that, this becomes 210 plus 7 equals 217. And I got that from doing 7 times 30 plus 7 times 1. I think I can go one more. Let's check. I'm going to try 8. 8 times 30 plus 1. 8 times 30 makes 240, plus 8 times 1 makes 8, which is 248. So 8 is our quotient. It is 248 because we just did the math quickly in our heads, and it's 0. So my answer is 8 shelves. There were a total of 154 basketball games in the season. The season is played for 11 months. How many basketball games were played each month if each month had the same number of games? So again, I'm saying this word each month, and that indicates to me that I need to do a division problem. The 11 goes with months, so that becomes my divisor. So it's 154 divided by 11. So we'll go ahead and set up our division problem. 11 goes into 15 one time. I subtract, I get 4, bring down my 4. 11 goes into 44 4 times. It is 44. I subtract, I get 0. My quotient tells me that there were 14 games per month. There are 1,110 students at school. If each classroom holds 30 students, how many classrooms are needed at school? Again, here is that word, each, and it is each classroom, and it's asking how many classrooms. So 30 becomes my divisor. So 1,110 divided by 30 is my number sentence. I'm going to go ahead and set that up. Whoops. So I say, how many times does 30 go into 1? It doesn't. How many times does 30 go into 11? It doesn't. How many times does 30 go into 111? Well, because it has a 0 on the end, I can kind of take that away and say, well, how many times does 3 go into 11? It goes in there 3 times. 3 times 30 makes 90. And I subtract. I got to borrow. So 11 minus 9 is 2. 1 minus 0 is 1. And I bring down the other 0. And I say again, how many times does 3 go into 21? It goes in there 7 times. So that is 210, because 3 times 7 is 21, plus a 0 on the end. And that makes a 0 remainder. So we would need 37 classrooms. And again, I can check my answer by multiplying my quotient times my divisor to see if I get to my dividend. John walked half a mile yesterday and 3/4 of a mile today. How many miles has John walked? So I'm looking for a total amount of time, miles walked. So since he walked a half a mile yesterday plus his 3/4 of a mile today, we want to know how many miles altogether. I cannot add fractions with uncommon denominators because I have to have common parts in order to do that. So what I'm going to do is I'm going to go ahead and put 2 and 4 inside my ladder to find the least common multiple. And when I do that, I see 1 and 2 doesn't have another common factor. I multiply all the way around. Remember, it's like multiplying around the L, which makes 4, which is my least common multiple. And then becomes my least common denominator. I see that 4 is already on the bottom here, so I'm not going to change 3/4. But 1/2, I'm going to put 4 on the bottom for my common denominator. So times 2 makes 2/4. So my new problem becomes 2/4 plus the 3/4 is going to equal 5/4. Once we have our common parts, the numerator or denominator just slides over. 5/4 is improper, but another way of saying 5/4 is 5 divided by 4. So 5 divided by 4. 4 goes into 5 once. I subtract, I get 1. My remainder goes over my divisor. So my answer is 1 1/4 miles. A football player advances 2/3 of a yard. A second player in the same team advances 5/4 of a yard. How many more yards does the second player advance? How many more indicates a subtraction problem. I know 5/4 is going to come first because it is improper, which means it's greater than 1. 2/3 is a fraction, which means it's less than 1. So my number sentence will look like 5/4 minus 2/3. I'm going to go ahead and put 4 and 3 inside the ladder. I see they only have a common factor of 1, so basically we're just multiplying them, which becomes 12. That's my least common multiple, which becomes my least common denominator. Both fractions have to be changed to have 12 on the bottom. So I'm going to put both fractions in the ratio table. So we would do times 4 and times 4, which makes 8/12, times 3 makes 15/12. 5/4 came first. Subtraction is not commutative, so it has to go in the order that we see it. So 15/12 minus 8/12 equals 7/12. So my answer is 7/12 yards. What is 1/4 of a half? Well, 1/4 is written like this, and a half is written like this. And I have to decide if I'm adding, subtracting, multiplying, or dividing. The key word here is of. Of always means to multiply. So we're going to be multiplying these two fractions together. Remember, when we went to act this out, 1/4 was like this. And we're going to multiply it by 1/2. Remember, which looks like this. Okay, which means this is all going to slide together. So this line is going to slide over here, and then this is going to go like this. And we see that there is 1 out of 8 pieces that overlaps. So my answer is 1/8. The Bazooka bubblegum tape is 6 feet long. How many 2 1/4 inch pieces can the tape be cut into? So in order to figure out this problem, first of all, it says how many of these pieces can fit into that. This is a division problem, which is going to look like 6 divided by 2 and 1/4. So now I'm going to act it out. I'm going to make 6 look like this. 1, 2, 3, 4, 5, 6, and this would all be together for our Bazooka bubblegum tape, but for math purposes we'll separate into 6 same pieces, and I'm going to divide it by 2, 1, 2, and 1/4. And 1/4 is going to be like this, and it's extra. So what I'm looking at is how many of all of this up to this 1/4 can fit into here. Well, it's hard for me to determine that because they're not equal parts. So I'm going to separate everything into fourths since this is already into fourths. So let's go ahead and separate everything into fourths, and all of these would be colored in because it's 2 and 1/4 more. And then all of these would be colored in, but to save time, I'm not going to do it. So now everything's in fourths, which makes this much easier to see. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of fourths. So how many 9/4 fit into all of this? So I'm going to count by groups of 9. So here's 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is one group. Then I'm going to count starting at the end here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the second group. And I'm going to count 1, 2, 3, 4, 5, 6 out of the 9 pieces that are left over. So it's like my remainder. So I have 2 and 6 9s. I know that 6 9s can be simplified because they have a common factor of 3. So I'm going to divide by 3. Divide by 3, top and bottom, make it equal. 6 divided by 3 is 2. 9 divided by 3 is 3. So my final answer is it can be cut into 2. How many 2 1/4 inch pieces can be cut, the tape be cut into? It can be cut into 2 2/3 pieces. Ellen wanted to buy the following items: a DVD player for $49.95, a DVD holder for $19.95, and a personal stereo for $21.95. Does Ellen have enough money to buy all 3 items if she has $90 with her? So we're looking at going to the store and buying these items, which means we're going to add them all up. And when I add decimals, I have to line up my decimal points. So this becomes $49.95, $21.95, and $19.95. And notice they're not in order, which is fine because addition doesn't have to be in order. I'm not adding in the $90 because I'm comparing it to the $90 to see if she has enough money. So when I add, I do one place value at a time, starting with the smallest place value. 5 plus 5 is 10, plus 5 is 15. Carry the 1. 3 9s makes 27, plus 1 makes 28. Carry the 2. 18, 19, 20, 21. Carry the 2, 6, 7, 8, and 9. And remember, my decimal drops straight into my answer. So she would spend on all 3 items $91.85. So no, she doesn't have enough money because she only has $90. If a 10-foot piece of electrical tape has 37 thousandths feet cut from it, then what is the new length of the tape? This problem, it's telling you it's taking away 37 thousandths a piece. So this is a subtraction problem. So our problem becomes 10 minus 0.037. So when I set it up, 10 has to go on top, even though this number has more place values. In subtraction, it's not commutative. So now I have to line up decimal points. So I see the number 10. All whole numbers have an invisible decimal at the end, because then we start our place value system, our decimal place value system. Or you can think of it as money, $10. And I know where to put my decimal. And then I line up decimal points, 0.037. Since I don't have enough decimal places on top, I can put another 0 in there. It doesn't change the value, it just changes the way it looks. In order for me to subtract, I cannot take 7 from 0, so I have to come all the way over here and borrow. This becomes a 0, this becomes a 10. Borrow from my 10 makes it a 9, makes this 10. Borrow makes it a 9, makes this 10. Borrow from it makes it a 9, this becomes 10. Now I can subtract. 10 minus 7 is 3. 9 minus 3 is 6. 9 minus 0 is 0. 9 minus 0 is 0, and my decimal drops right in. So it would be 9.063 feet left over. And if I looked at just estimating, it would be 10 minus 0 is 10. Well, my answer is close to 10. At least I know I have my decimal place in the right spot. A student earns $11.75 per hour for gardening. If she works 21 hours this month, then how much did she earn? So what we're looking at here is a kind of repeated addition, because we know how much she works for 1 hour. We could calculate out for 2. We calculate out for 3. So repeated addition becomes multiplication. It doesn't matter which number we put on top. I prefer the one with the most place values on the top. And remember, we just go ahead and we multiply like normal. 5 times 1 is 5. 1 times 7 is 7. 1 times 1 is 1. 1 times 1 is 1. Put a 0 here because I've already used this place value. 2 times 5 is 10. Carry the 1. 2 times 7 is 14 plus 1 is 15. Carry the 1. 2 times 1 is 2 plus 1 is 3. 2 times 1 is 2. And then I go ahead and I add it up because I've multiplied each number by the other numbers. So 5, 7, 6, 4, and 2. There are 2 decimal places in my problem, so I need 2 decimal places in my answer. So my answer is $246.75. Rick's car gets 29 7/10 miles per gallon. If his fuel tank holds 10 4/500 gallons, then how far can he travel on 1 full tank of gas? So again, this is a multiplication problem because it's telling us per gallon. So we know how much in 2, we know how much in 3. We have to get up to 10 4/500 gallon. So we're going to go ahead and put 10 4/500 on the top and 29.7 on the bottom. Again, remember, it doesn't matter if the place values, they don't have to be lined up. It's like doing 1045 times 297. So I'm going to go ahead and start multiplying. 7 times 5 is 35. Carry the 3. 28 makes 31. Carry the 3. 7 times 0 is 0 plus 3 is 3. 7 times 1 is 7. I've used this place value, so I'll put a 0 there, and I start with the 9. 9 times 5 is 45. Carry the 4. 9 times 4 is 36, plus 4 makes 40. Carry the 4. 9 times 0 is 0, plus 4 is 4. 9 times 1 is 9. So now I've used this place value and this place value. I like to mark them off, all my other work, and I start with the 2. 2 times 5 is 10, carry the 1. 2 times 4 is 8, plus 1 is 9. 2 times 0 is 0, and 2 times 1 is 2. And I add up all the numbers. 5, 6, 3, 13 plus 7 is 20, carry the 2, 9, 10, 11, carry the 1, makes 3. I go back to my problem. I see 1, 2, 3 place values. I start here, 1, 2, 3. So they can go approximately 310 and 365 thousandths miles on their tank of gas. A store owner has 7 1100 pounds of candy. If she puts the candy into 9 jars, how much candy will each jar contain? Again, here's our key word of each jar. The 9 goes with jar, so the 9 is our divisor. Most of you would want to set it up 9 divided by 7.11, but it is actually 7 and 11/100ths divided by 9 because the jars matches what the problem is asking me to do. So 7.11 goes on the inside. 9 is my divisor. How many times does 9 go into 7? It doesn't, so I could put a 0 there. How many times does 9 go into 71? It goes in there 7 times, which makes that 63. And I subtract. Can borrow, make that 6, make that 11. That makes 81. 9 goes into 81 9 times. That is 81. I subtract, I get 0. And since I know that I'm taking a smaller number divided by a larger number, my answer is going to be a decimal. My decimal is straight up into my answer. She would have 0.79 of a pound of candy in each jar. What is the average speed in miles per hour of a car that travels 956 and 4/10 miles in 15.9 hours? So again, average speed means per one, and we want our miles per hour. Since 15.9 is hours, that's our divisor. So we have 956 and 4/10 divided by 15 and 15.9 excuse me, 15 and 9/10 hours. So 956.4 divided by 15.9. We can't divide decimals by decimals, so we have to make our divisor a whole number. So I do that by multiplying by a power of 10. So it becomes 159, and this one decimal point also has to move one place to the right. It has to happen both inside and out. So now I've got 159. How many times does it go into 9? Doesn't. 159, how many times does it go into 95? It doesn't. 159, how many times does it go into 956? So I'm going to go ahead and use my distributive property. And I'm going to go ahead and start with 4. So this is going to become 4 times 100 plus 50 plus 9. Okay, there's my 159. And that becomes 400 plus 200 plus 36. So it's 636. I think I can go higher than that. So let's try 5. Becomes 500 plus 250 plus 45. So that becomes 750, so 795. Let's try, I think I'm going to try 8. I'm going to jump it up a little bit. Comes 800 plus 400. Whoops, that's going to be way too much. Plus 72, that's like 1200. So let's try 7. Oops, I'm getting in my problem there. 7 times 100 plus 50 plus 9 makes 700. All right, too much there. That's already 1,000. So I guess it was 6. And that's okay if we do a little bit of math off to the side. 600 plus 300 plus 54 becomes 954. Wow, that was very close. Okay, so here we go with our 6. 954. Oops, sorry. And I subtract, I get 2, and I drop down my 4. How many times does 159 go into 24? It doesn't. That's a 0 there. So I'm going to add a 0 on the end. How many times does 159 go into 240? So we could try twice, which I think is going to be too much. So we'll do once, which is 159. And I subtract. And see, my answer is telling me to round to the nearest tenth. So we're going to stop at this point in time. So I'm going to borrow from here, make it a 3. 10 minus 9 is 1. Can't do 3 minus 5. 13 minus 5 is 8. So I'm going to go ahead and put one more 0, drop it down. 810 was close to 5 times, which was 795. See how that work really paid off? Okay, I subtract. Borrow, that's 5. Borrow, that's 1. Okay, so right here, my decimal is going to go straight up into my answer. And I have 2 decimal places, and it says round to the nearest tenth. Well, the 1 is in the tenths place. I look to the 5. The 5 tells the 1 to round up. So my answer is 60.2 miles per hour. And that would be my final answer. Okay, it says Larry worked 15 days for a total of $116 116.25 hours. How many hours did he average per day? So we're looking at how many hours, and he worked 116.25 hours in the 15 days, but how many hours did he average per day? Excuse me. So my per day goes with my 15 days. So I get 116.25 hours total divided by my 15 days because I'm looking for my per day rate. So again, I'm going to go ahead and set up my problem here. Divided by 15. 15 doesn't, no groups of 15 fit into 1 or 11, so I have to figure out how many times it goes into 116. So I'm going to go ahead and start with 7 times 10 plus 5 makes 70 plus 35, which is 105. So we can try one more time. 8 times 10 plus 5, and if you're wondering where I got the 10 plus 5, that's my divisor, separated by place values, becomes 80 plus 40, which is 120. So it goes in there 7 times, which is 105. I subtract, I get 11. I drop down to 2. So again, I know it goes in there another 7 times because 8 was too much. So that is another 105, which I subtract, makes 7, bring down the 5, and 15 goes into 75 5 times. That is 75. I subtract, I get 0, and my decimal goes straight up into my answer. So they work 7.75 hours per day. In this problem, there are 2.54 centimeters in 1 inch. How many inches are there in 51.78 centimeters? It says round your answer to the nearest thousandth. So we're looking at this being a division problem because it says here in 1 inch, or that means like per inch. So I'm looking at taking my 51.75 and, 78, and I'm dividing it by my 2.54 centimeters in 1 inch. Those go together, and since I'm looking for how many inches, so this becomes my division problem. So I'm going to go ahead and set it up. 51.78 divided by 2.54. And since I can't divide by a decimal, I need to get rid of it by moving it 2 places to the right, multiplying it by 100, moving this one 2 places to the right. And again, I said this should be an 8. And my decimal goes straight up. Let's make that an 8, sorry. Okay, so now we got 254 goes into 517. So, because this decimal now is gone, it moved over 2 places. So I'm going to take and multiply by, I'm going to separate out by place values, and I'm going to distribute to make my math a little bit easier. So this becomes 400 plus 200 plus 8, right? 2 times 200, 2 times 50, and, 100. So this becomes 508, which is pretty close. So this goes in there twice, all the way out to the 7, because I did 517. That becomes 508. And I subtract, I got to borrow here. 17 minus 8 is 9, and I drop down the 8. Since I dropped down the place value, I have to check to how many times does 254 go into 98. It doesn't, so I put a 0 there. So now I have to create another place value by adding a 0. So I'm going to try and find out how many times 254 goes into 980. I'll try 3 times. So that's 200 plus 50 plus 4. So that makes 600 plus 150 plus 12. So this becomes 750 plus 12 makes 762. Okay, now I think maybe we can try one more. Let's try 4 times 200 plus 50 plus 4 makes 800 plus 4 times 50 is 200 plus 16. So that's too much. That's 1016. So it goes in there 3 times. And that's 762. Okay, I'm going to borrow. This becomes a 7. This becomes 10. 10 minus 2 is 8. 7 minus 6 is 1. 9 minus 7 is 2. So we got 218. I'm going to create another place value. I have to go out to the thousandths. So I have to go out like 4 place values just to be able to round. So I'm not really close here. If I double that, that becomes 2032. So we can try jumping over here to 8. Okay, so let's try 8 times 200 plus 54 plus, plus 50 plus 4. Okay, so that becomes 1600 plus 400 plus 32. So that becomes 2032, like I said, because we doubled it. And I don't think I'm going to be able to go another one, so that goes in there 8 times. It's 2032. And I subtract 8, 4, 1. Create another place value by putting a 0. 1,480. We'll try one more time. We'll do 5 this time. So 5 times 200 plus 50 plus 4 makes 1,000 plus 250 plus 20. So that's 1250. So 1270. I think if we go another one, we'll go too much. So this is going to become a 5 here. 3 place values out will be 1,270. 0, 1, 2. And we'll bring down another place value, so 2,100. So that goes in there 8 times. We already had that worked out. That's the nice thing about doing all the math off to the side. You already have it. I don't have to subtract it this time. So I see that I'm rounding to the thousands, tenths, hundredths, thousandths. This one tells this one what to do, so I have to round up. So my answer is 20.386 inches in 51.78 centimeters, which is about 20 inches in those 51 centimeters.